In this video, I want to show how two-stroke carburetors work. These are typically found on equipment like chainsaws and weed eaters. These carburetors are very small, and the pieces inside of them are very tiny. So I've 3D printed this large-scale model to make it easier to see how it works. I've also made this cutaway of the fuel metering area so you can see how the metering lever works and the inlet needle. I've also made this cutaway of where the high and low speed adjustment screws are so you can see what happens when you adjust these. There are many variations of these two-stroke carburetors, but the principle and how they work is the same. This particular one is a Walbro brand carburetor, and it's a WT series and a model 624. I'm going to start here where the fuel pump is under this cover. Under this cover is a gasket and the fuel pump diaphragm. And here you can see the same thing on the larger scale model. This fuel pump is controlled by this pulse port that's found in the side of the carburetor body. On the engine cylinder, this is where the carburetor would mount. There's a hole here that goes into the crankcase, and that matches up to the pulse port on the carburetor. There's a crankcase cover that goes on here, and it's sealed to the cylinder. There's also seals around the crankshaft, so this entire area is sealed off. So as the piston is going in and out, it alternates between creating a vacuum in the crankcase to pressurizing it. That vacuum or pressure goes out through this little hole here in the side of the cylinder, and that's what comes out here and into the pulse port on the carburetor. So with the fuel pump cover removed, you can see where the pulse port here extends up through this hole, and that matches this hole in the cover, which then goes through here into this area, and that covers this area here. I've made another fuel pump cover that has the top cut off, so you can see it on here, but you can also see the various chambers inside of it. And here again is that pulse port that comes up through here and through this area into this chamber. So when the piston's going up and creating a vacuum at the pulse port, which ultimately ends up in this chamber, it pulls up on this diaphragm, just like this. So when it pulls up on this diaphragm, it creates a vacuum in this area, and this is the fuel reservoir. So there's a vacuum created here. That vacuum is also through here and through this hole here. That hole you see is here. The vacuum draws fuel in through the fuel inlet tube, and it pulls this flap up, drawing fuel in from the tube through this hole into this one and into the fuel reservoir. In the fuel reservoir, there's also a hole on this side extending to here, and that is also covered by a flap. But because it's creating a vacuum, it's pulling the flap down, sealing this side off, and only pulling fuel through the inlet tube and under this flap into the reservoir. Now when the piston's coming back down, it's creating pressure in the crankcase, and that pressure is through this pulse port, again through here, only this time it's pushing down on this diaphragm. Pushing down on the diaphragm, creating the pressure in the fuel reservoir. The pressure through this hole and this one again comes into this chamber. Now the pressure is pushing down on this flap, holding it down so the fuel cannot be pushed back through the inlet tube. Pressure on this side of the fuel reservoir forces fuel through this hole, and it comes out this one. That hole is under this flap, so it pushes this flap up, filling this chamber. The fuel then goes down through this hole, and this hole leads to here. This is the inlet to the metering side of the carburetor. So when the engine is running, it is constantly alternating between vacuum and pressure, pulling this diaphragm up and down, pulling fuel from this side into the reservoir and pushing it out this side through this hole and into the fuel inlet side for the metering. I've added this red pipe cleaner to the carburetor to show you the path of the fuel through the inlet and this hole. And you can see where it comes under this flap and then into the fuel reservoir, out through this flap and into the metering chamber. Before the fuel goes into the metering chamber, it goes through this screen, and this screens out any debris that may have gotten into the fuel. And now with the screen removed, you can see this brass insert, and this is where the fuel goes to the other side of the carburetor, to the metering side, through this hole. So now I'm going to flip the carburetor over and we'll look at the metering side of the carburetor. This is the metering cover, and I'm going to remove it so we can take a look inside. Underneath the cover is the metering diaphragm, and that consists of this flexible material with this metal disc and a button in the middle, and that button pushes down on the metering lever. So after the fuel enters this area and through this brass insert, it comes out this side where this inlet needle is, and it floods this entire area. As fuel from this area is drawn into the engine, it creates a vacuum on this side, and it pulls down on this diaphragm, and this button pushes down on this metering lever and raises this inlet needle to allow more fuel into this area. Here's the cutaway to show how that works. So as fuel from this area is pulled into the carburetor, there's a low pressure or a vacuum on this side. On the cover there's a small hole here that allows atmospheric pressure, which is a higher pressure on the top side, moving this diaphragm down, and this little button pushes on the metering lever. The metering lever is held up by a spring, so this is normally closed. When the diaphragm is pulled down, the lever pivots on this pin, so it raises the inlet needle off of its seat in this brass insert. And that allows more fuel through here into the metering area. This inlet needle has 3 ribs on it, and that helps guide it up and down in this hole here. And you can see on this one the ribs stick out to help guide it, but the fuel can run in between them and up through here into the metering area. The fuel in this area goes through this check valve and past the high and low speed adjustment screws. On some models the check valve is only connected to the high-speed adjustment screw. I'm going to remove this check valve to show you how that works. The fuel can go through this hole on this side, and it comes out on the other side. You see there's a little rubber disc in here, and that floats to prevent back pressure coming in from this side. Here's a larger cutaway of that check valve, and you can see where the fuel runs in from this side on the top of this rubber seal. And the rubber seal is slightly smaller, so there's gaps around the perimeter for the fuel to run around here, and these tabs hold it up. So the fuel runs around this seal and can come past these tabs and out and through the carburetor. When there's back pressure coming up this direction, it pushes this seal up against the hole so that fuel does not go in the other direction. Here's the actual check valve that would go into the carburetor right here, and you can see how very tiny that is. Once the fuel goes through the check valve into this area, it can go through this hole here past the low speed adjustment screw, or through this hole past the high speed adjustment screw. When it goes in this direction past the low speed adjustment screw, it goes through a port in here, and the fuel ends up in this area. In this area is the idle fuel port and the two low speed fuel ports. When these carburetors are made, there's a cast aluminum body, and then these tiny little holes need to be drilled through into the throat of the carburetor. After they're drilled, this area needs to be plugged. Otherwise, fuel will just run from this area through these ports without being metered. To plug or cap this area, they use something called a Welch plug. It's made of a very soft metal. It's convex on the top, concave on the bottom, and when you put it in, then it's use a special punch and hammer and tap it in the middle. That flattens it out, spreading this material out and wedging it into this hole so that fuel can't leak through it, and it holds it in place. And here's another carburetor where the Welch plug is still in place. You can see it here. So the fuel that goes through here and past the low speed adjustment screw and into this area goes through this idle fuel port, and then there's also the two low speed fuel ports. And the fuel goes through here and comes out this little hole here into this area. So the high speed side also has a Welch plug in place. And the fuel going past the high speed adjustment screw goes through this hole here and comes out this one and into this area. And here you can see there's a screen in this area and a ring clip that holds it in place. And here's the ring clip that holds the screen in, and the screen. And below that is this hole that goes through the throat of the carburetor. And here's a cutaway of that area showing the adjustment screws. And again, the check valve, I'll remove that. And you can see where the fuel would go through here onto the low speed adjustment side. And here's the adjustment screw. There's an O-ring or a seal here to prevent fuel from going back this way past the threads. The fuel would go out through this hole and into here. And it's kind of hard to see, but the ends of these screws are tapered. So the more you adjust this out, the bigger the gap is between the screw in this hole, allowing the fuel into this area, through here, up through this hole, and into this area. On the high-speed side, it would go down through this hole, past the screw, and in through this hole, into this area, and into the throat of the carburetor. And you can see when you adjust these screws, you start by turning them all the way in and then backing them out. You never want to turn it in too tight because you could damage the softer aluminum in this area. Some of these carburetors on the adjustment screws, they can be adjusted with a standard flat screwdriver. This particular carburetor, on the screws, they're splined, and this requires a special tool to adjust them. This one uses a 21 splined end on the tool. Here you can see what that would look like on a larger scale. Here you can see the adjustment screws have springs on them. This keeps tension between the body of the carburetor and the collar on the screw so that vibrations doesn't make them move in or out. There's also this spring clip that squeezes together the springs and puts additional pressure on them to prevent these screws from moving in or out. This is the choke valve on the carburetor. This is where the air initially comes in. When first starting the engine, this is fully closed. There's a small hole here allowing some air to flow in. This is closed so that mostly it pulls fuel into the engine to get it started. Once the engine starts, the choke is moved to partially open. And this gives the engine a chance to warm up. It needs to be warm to vaporize the fuel. And once the engine is warmed up and running properly, then the choke is open fully to let the maximum amount of air through here. Behind the shaft here, there's a detent ball and a spring, and that's what holds the choke into its various positions. If I just slide this shaft back, you can see these divots or pockets in the shaft where the ball goes in and holds the shaft in the partially open, fully open position. And there you can see the detent ball, and there is a spring behind it. And here in the venturi, you can see this small hole here that comes from the high-speed adjustment screw side. So there's a lot of air comes into this area. The venturi, being smaller, speeds up the air passage and pulls fuel from this through the throat of the carburetor. On the throttle valve side of the carburetor, and this would be the side against the engine, you can see this small hole here, and that is the idle fuel port hole, and that's the one that comes from this area. And this is where the fuel comes in when the engine is just idling. Here's the idle adjustment screw, and it also has a spring on it to keep tension so that it doesn't move in or out. As you adjust the screw inward, this taper on the end of the screw pushes against this plate, and the farther it's screwed in, the farther it pushes this plate open and opens the idle valve. And this is how you adjust the idle setting on your engine. And this plate is spring loaded to keep the throttle always closed. So when you release the trigger, it goes back to idle. So just to go over the whole process one last time, the fuel comes in through this fuel inlet, into this hole, into this chamber, through this hole, into this fuel reservoir. From here the fuel is fed in through this hole, out this one into this chamber, through this hole, which comes out here, and through this fuel inlet to the metering side of the carburetor. From the metering side of the carburetor, when the metering lever is pushed down, the fuel comes up through here, past the metering inlet needle. That fuel then goes through here, the check valve area, either through this hole to the load speed area, comes out this hole and into the idle port, or either of these two holes. At high RPM, the fuel is pulled past this high speed screw and through out this hole, through this one, and into the throat of the carburetor here. Hopefully this video has given you a better understanding of how a two-stroke carburetor works. And again, this was based on a Walbro brand, WT series 624 two-stroke carburetor.